Hello everybody, Namaste. Welcome back to my YouTube channel. I'm Anushka, currently studying in Sri Venkateswara College of Engineering, and today we'll be looking at bubble sort. Introduction to bubble sort. Bubble sort is a simple and intuitive sorting algorithm that repeats steps through the list, compares adjacent elements, and swaps them if they are in the wrong order. It gets its name from the way smaller or larger elements bubble to the top of the list. Let's understand the algorithm, and we'll be moving into an example as well. This simple sorting algorithm, it iteratively compares pairs of adjacent items and swaps them if they are in wrong order. The process is repeated until no swaps are needed, indicating the list is sorted. The larger element is sorted to the back and the smaller elements are sorted in the front. So the order of the sorting is from smaller to the larger number. Here, the way in which the sorting happens seems to be like the larger elements are bubbling in the bottom or the end, and the smaller elements are in the beginning. Let's check out the algorithm. For I from 1 to n, where n is the number of elements, for j from 0 to n minus 1, if item j is greater than item j plus 1, swap item j, comma item j plus 1. Here, we also use a temporary variable to temporarily store the number that needs to be compared. Moving on. Understanding the bubble sort algorithm. Compare adjacent elements. The algorithm starts by comparing the first two elements in the list. If the first element is larger, it is swapped with the second element. Move largest element to the end. The algorithm continues to compare and swap adjacent elements, moving the largest element to the end of the list. Repeat the process. The process is repeated for the remaining unsorted portion of the list until the entire list is sorted. Let's understand this step by step. The initial list is 5, 2, 8, 1, 9. First, the first element, that is I is equal to 0, is compared to j equals to 0 from I from 1 to n and j from 0. So here the 5 is compared to 2. So 5 and 2 are compared and it is swapped as 2 is a smaller element than 5. Then it compares 5 and 8. All right. And since 5 is smaller than 8, the 5 remains there. It compares 8 and 1, it swaps, and compares 9 and 8 and 9, no swap. The list is 2, 5, 2, 5, 1, 8, and 9. This 5 is first compared to 2, where 2 is smaller than 5, so 2 goes to the first. Then 5 is compared to 8, as 5 and 8, 5 is smaller, it remains there. 8 is compared to 1, as 1 is smaller than 8, it moves to the front. 8 and 9 are compared, as 8 is smaller than 9, there's no swap. In the second comparison, 2 and 5 is compared. Again, from here, we're going to check now. 2 and 5 is compared, no swaps. 5 and 1 is compared, as 5 is greater than 1, 1 comes in the front. Then we have 5 and 8 is compared, there's no swap. 8 and 9 is compared, there's no swap. The list is now 2, 1, 5, 8, 9. Finally, 1 and 2 will be compared and 1 moves to the front. Time complexity of bubble sort. Let's understand time complexity, which indicates the order of growth in any of the algorithm. The best case scenario. If the list is already sorted, bubble sort only needs to make one pass through the list, resulting in time complexity of notation big O of some function n. Average case. In average case, the bubble sort needs to make multiple passes through the list. Resulting time complexity is big O of some function n to the power 2. Worst case scenario. In worst case scenario, the list is sorted in reverse order. That is, instead of ascending order, or if we need descending order, it is arranged in ascending, and if we need ascending, it's arranged in descending order. So in this list, the elements are sorted in reverse order. Bubble sort needs to make the maximum number of comparison and swaps, resulting in the time complexity of big O notation n to the power 2. Let's understand the advantages and disadvantages of bubble sort. Advantages. Bubble sort is easy to understand and implement, and it can be useful for small data sets or nearly sorted lists. Disadvantage. Bubble sort has a slow time complexity of or big O notation n to the power n square, making it inefficient for large data sets. It also has a high number of comparisons and swaps, leading to poor performance. As sorting algorithms are usually worst case scenarios or worst case efficiencies, since the number of comparisons is always high while sorting, at times the sorted list might be given out, but sometimes the list might not be sorted. Now, implementing bubble sort in code. We have array. Bubble sort operates on an array data structure, swap. The algorithm compares the swap adjacent elements. Loops, nested loops are used to iterate through the array and perform the sorting process. Optimization. Techniques like stopping can be used to improve the efficiency of bubble sort. Optimizing bubble sort. Optimize bubble sort. Reduce unnecessary swaps. Track whether any swaps were made during a pass. If no swaps occurred, the list is already sorted and the algorithm can stop. Adaptive bubble sort. Modify the algorithm to stop the inner loop earlier if the current element is already in its current position. Optimize bubble sort. Combine these techniques to create an optimized version of bubble sort that can outperform the basic implementation of the current cases. Conclusions and takeaways. Simplicity. Bubble sort is a simple and intuitive sorting algorithm that is easy to understand and implement. Inefficiency. Bubble sort has a time complexity of big O notation n to n square, making it inefficient for large data sets. Optimization. Techniques like earlier stopping and adaptive sorting can be used to optimize performance of bubble sort. Use cases. Bubble sort can be useful for small data set or nearly sorted list, but is generally not recommended for large scale sorting. And that's it for today. I hope you have understood something about bubble sort and you can have various examples in order to understand this. I'll see you in the next one. Thank you so much.